Hi. Let us now start looking at how to find the asymptotes of the functions. We have looked at how to find the domain and range of the functions, and we have done for rational functions. We did also for quadratics, linear, and many other type of functions. Now let's look at the next idea, big idea, which is the how to find the asymptotes of a function. First, we should know what are the asymptotes. So let me show you a graph and see what do we exactly mean by asymptotes. So if you look at this graph that you see on the right side of the screen, what's happening here? You can see there are two dotted lines. One is a vertical line at x equal to 2, and one is a horizontal line y equal to 4. Right? Now these two lines are those lines, or these are two lines on this graph which the function never touches. Is the graph going to touch these lines? No, it is approaching these lines. It is coming very, very close to these lines. But the graph is never going to meet these lines. And these are called the asymptotes. So x equal to 2 is a vertical line, so it is called the vertical asymptote. VA, I can shorten. And y equal to 4 is a line parallel to x-axis. So it's a horizontal line, and we can call it horizontal asymptote. So horizontal asymptote would be always a line which is y equal to some constant. So horizontal asymptote is y equal to a constant, whereas a vertical asymptote VA is x equal to some other constant, let's say h. Right? And these are the lines which the graph never meets, but it can approach. Now the question is how to find the vertical asymptotes and the horizontal asymptotes of any graph which has asymptotes. So what we do is we will look at some rules. Now to locate the vertical asymptotes are those values of x which are not allowed in the domain. So if we know how to write the domain, we know how to find the vertical asymptotes, because the domain decides the vertical asymptote. Now, if I look at this function, fx equal to 1 over x minus 4, you know, the domain of this function is all x values or all real numbers except 4. That means x equal to 4 is the vertical asymptote here. So the rule is, or the steps are, set the denominator equal to 0, solve for x, and this, whatever you solve x for, let's say x equal to 4 here, then x equal to 4 becomes the vertical asymptote because it's a vertical line parallel to the y-axis. Right? It actually means, if you look at the essence of it, it means that when x is equal to 4, the fx will become 1 over 0, which means it will go towards infinity. And infinity can never be touched. Infinity can never be touched. That is why the graph will never touch this. So vertical asymptote is that value of x which makes the y or the fx goes to infinity or minus infinity. If this was minus 1 on the top, then it will become minus infinity. Right? So those values of x which make the fx or the y become infinity or minus infinity are called the vertical asymptotes, and they are obtained by setting the denominator equal to 0 and solving for x. All those values of x which make the denominator go to 0 are called vertical asymptotes. So if I show you one more question here, let's say x over x square minus 1. Now which are the x values which make the denominator become 0? X square minus 1 is 0, so x square is 1, so x has now two values, plus 1 or minus 1. Therefore, this graph has two vertical asymptotes, x equal to 1 or x equal to negative 1. And if you have to, yes, you can see that there are two vertical lines, dotted lines, which are the asymptotes here. Right? That is the rule for the vertical asymptotes. Now, for the horizontal asymptotes, what do we do? Horizontal asymptotes similarly are those values of the function fx, which fx cannot take. Y cannot take. Fx means y, the values which y can't take. So we'll look at the range of the function. So if you can recall, or you can look at my videos for domain and range, it will become very clear to you that the range of this function is fx not equal to 0. Isn't it? This function range is, it can take all the values except 0. So fx not equal to 0 is the range. That means fx equal to 0 is the horizontal asymptote. Right? Because it means those values of fx when x goes to infinity. So when x goes to infinity, what will fx become? 1 over infinity minus 4, which is 1 over infinity, which is 0. right? So the fx is equal to 0 when x goes to infinity or minus infinity. And those are called the horizontal asymptotes. But it is not very easy to get the horizontal asymptotes, and we will discuss all the cases. There are three possibilities in case of horizontal asymptotes. So for finding a horizontal asymptote, the rule says first look at the degree of polynomial in both the numerator and the denominator. Degree means the highest exponent or highest power of the independent variable. More generally, it is the x. So if you look at the numerator here, it is x minus 1. What is the degree of x? It's 1, x to the power 1. In the denominator, it is 2. Right? So we have to look at degree of x in both the numerator and denominator and then compare those. Compare. If the numerator has a lower degree than the denominator, which is happening in this case, 1 is less than 2, then the horizontal asymptote is just y equal to 0, which is the x-axis. So for this, horizontal asymptote is y equal to 0. And you know, we have already done that this function will never become 0, right? And that can be proven very easily. Second part, if the numerator and denominator have the same degree, like this one, x square is there in the numerator and x square in the denominator. So both have same degree too. In that case, y equal to a upon b is the horizontal asymptote. A over b. What is a? A is the coefficient of x square in the numerator, 4. What is the coefficient of x square in the denominator? It is 1, 4 over 1. So it is 4. Right? And that is how so if the degrees are same, we will just compare the coefficient or take the ratio of the coefficients of the highest power of x in the numerator to the highest power of x in the denominator, and that becomes your horizontal asymptote. In case you say now the degree of the numerator is higher, then we have to carry out long division, you know. Then we carry out long division, and there is no horizontal asymptote. We will carry out long division, and from that we will get what is called an oblique asymptote, which I will discuss in the next video. But as of now, you can understand that if the degree of the numerator is greater than the degree of the denominator, then there is no horizontal asymptote. So horizontal asymptote will not exist in this question. Now, just to apply this to different cases here, can we look at the asymptotes here, both the asymptotes? What is the vertical asymptote here? Vertical asymptote is that x value which makes the denominator go to 0. So it is x equal to 2. And horizontal asymptote, we look at the degrees. What is the degree of the x here? It is x to the power 0, which is less than the degree of x in the denominator, which is 1. So horizontal asymptote is y equal to 0. Second one, B part, vertical asymptote is that value of x which make the denominator 0, so x equal to 3. And horizontal asymptote is going to be y equal to, this has, if I just take 1 over x minus 3, then y can't be 0. And if y can't be 0, then 2 plus 0 can't be 2. So horizontal asymptote is y equal to 2. Because 2 is being added to something which cannot be 0. When 2 is added to something which cannot be 0, then the whole thing cannot be equal to 2. So y equal to 2 becomes your horizontal asymptote. That means the graph will never touch the line y equal to 2. Is that right? Because if 2 was not there, then the horizontal asymptote was y equal to 0. And now 2 is being added, so become y equal to 2. Now in the C part, if you look at, again, vertical asymptote is that value of x which is not allowed, so it is minus 1. And horizontal asymptote would be, again, 2. 2 minus 0, it again 2. Is that right? What about this one? If I look at the vertical asymptote of this, it is going to be 2x plus 1 equal to 0, and then x equal to negative half. For horizontal asymptote, now we have the same degree of x to the power 1 and x to the power 1. So it will be y equal to, coefficient of x here is 1, coefficient of x in the denominator is 2, so it is 1 over 2. Right? And that is your horizontal asymptote. I hope this is clear. And then we can plot the graph on that. Thank you very much. And I will be continuing with this in the next video also. Thank you.